I wanted to talk today a little bit about neonicotinoids, or neonics for short, um, and a little bit about why we're so concerned about these pesticides, certainly from a pollinator perspective, but also ecosystem perspective, clean water, human health perspective as well, and why we think these pesticides are maybe emerging as some of the most ecologically destructive pesticides we've seen since DDT, and also, as mentioned, a growing concern for human health. But to start with the humble honeybee, this may be a little bit, known knowledge for the folks attending this call, but I think everybody here recognizes that pollinators are incredibly important. 1/3 of the food that we eat, or 1 out of every 3 bites of food, comes from crops that benefit from pollinators and require pollinators. And to give you a sense of what that looks like, and some folks may have seen this before, this is what the grocery store looks like in the world today, where we have pollinators and bees and butterflies and other folks. But this is what that grocery store looks like in a world where we lose our pollinating species. Certainly, we would have food, but we would have a lot less of it. Our choices would be much more limited. We would lose a lot of our most delicious and nutritious options, and everything would be a whole lot more expensive.
Hey, Dan, I'm sorry to interrupt you. Do you have a headset, a microphone, or can you sit a little differently? It's waving in and out a little bit.
Let me try and microphone. Does this sound better?
I'm not sure yet, but let's try it.
So let me keep talking a little bit, and if this is a problem, I have one more emergency fix that I can use. Beyond the grocery store aisle, over something like 80% of the plants on the face of the earth require pollination from pollinators. So that includes bees, butterflies, birds, bats, and a host of other insects. So if we continue to lose pollinators, we worry not only about food scarcity and shocks to our food system, we worry about the collapse of ecosystems. And that is exactly what we did start worrying about in the mid-2000s, when beekeepers in Minnesota, in Illinois, and across the country started seeing their annual losses of honeybee colonies shoot through the roof. Up until that point, beekeepers were used to losing maybe 5 to 10% of their colonies, maybe 15 in a bad year, mostly to winter cold. But those numbers jump from 5, 10, 15% to 30, 40, 50%, and virtually overnight. And those losses we've seen continue to this day. Actually, last year, we saw the worst losses that we saw on record, with beekeepers losing about 55% of their colonies. And what we've heard actually recently is that those losses have persisted in January and February, with some pretty heavy losses as well. And one other trend that we've seen is that summer losses, it used to be very uncommon for beekeepers to lose their hives in summer, but some years the summer losses even exceed those winter losses, and they're substantial every year. So we know something new and different was happening with honeybees that were causing these mass die-offs. We also know that what is happening to honeybees is happening more broadly in ecosystems with all sorts of pollinators. There's 4,000 species of bees alone in North America. The honeybees not even being native to the United States. And a lot of these other species we don't count. We don't have numbers for. Honeybees are essentially livestock, so we know how many colonies we have. But the same is not true of our countless wild pollinators. And there's already effects from that. We know that apple, blueberry, and cherry production is already limited nationwide. And that's not just because of a lack of honeybees. It's also because of a lack of these wild bees, which are often more important pollinators, or more effective pollinators rather, than the honeybees for certain crops. And we also have a situation now where our honeybee colonies are about as weak as they've ever been, even though beekeepers every year replenish the lost hives, again, which doesn't happen with those wild species. So there's a lot of problems impacting pollinators, right? That's the scenario. We know pollinators are dying. We know it's been a big problem for the last couple of decades. Climate change is an issue. Parasites, pathogens are an issue. Habitat loss is an issue. Why are we talking about neonics in particular, right? Why are we talking about pesticides in particular neonics? And I think it's first helpful to know what neonics are. So neonics are neurotoxic insecticides, which means they are pesticides designed to kill insects by attacking their nerves. And they do that by responding, by addressing the nerve site, the insect nerves that responds to nicotine. And what they do is they attach to those nerves permanently and stimulate the nerve, overstimulate it until that nerve dies, right? So if you've seen a bee, for example, that has been acutely poisoned with neonics, oftentimes that bee will start to twitch uncontrollably before becoming paralyzed and dying. But a lot of pesticides kill insects in gruesome ways. Again, why neonics? And there are three big reasons. The first is that neonics are super duper toxic to bees and other insects. And to give you a sense of scale here, the thin neonic coating on one corn seed, and I'll explain what that is in a second, has enough active ingredient to kill about 250,000 bees. And in fact, neonics have made US agriculture close to 50 times more harmful to insect life since their introduction. If you look at where that harmfulness really begins to spike, it's almost exactly at the same point that we see a massive spike in losses of honeybee colonies. So again, we have all of these factors that are affecting bees, right? Climate change, habitat loss, etc. But none of them suddenly spiked around 2006, 2007. We do see that signature with neonics, and it maps almost perfectly with sort of these recent mass pollinator losses. And this spike, by the way, is when neonics started to be adopted widely as seed coatings, which I'll explain now. So the second problem with neonics is that they're really good at contaminating whole ecosystems. They are designed to permeate plants, meaning they get into the leaves, the roots, the pollen, the nectar, everything. And the idea is the plant itself becomes pesticidal, right? The plant itself becomes the pesticide. And that means you can apply neonics in all sorts of interesting ways. Of course, you can spray them, and they are often sprayed, but more often they're applied to soil, or most often they are literally painted on crop seeds. And here's a picture of some neonic treated corn seed that's not digitally enhanced. Here's a close-up. They don't have to pick the same color. They just have to colorize it to make people see that there's pesticide on the seed. And the idea is, as that seed is growing, it will literally soak up that pesticide coating through its roots and become toxic. The problem is only 2 to 5% of that coating actually gets into the target plant. The other 95+% stays in the environment. Some of it's released as dust, and I've actually seen numbers here as high as 10%. But the vast bulk stays in the soil where it persists for years and years and years. And those same properties that let the neonics get up into the plant, namely they dissolve readily in water, they're very water soluble, means that anytime it rains, anytime there's irrigation or lawn watering in a lawn context, those neonics are moving through the soil, they're contaminating new soil. If there are plant roots in that new soil, those plants soak up the pesticides, they become toxic, their pollen, their nectar. If there's a water supply nearby, that water supply becomes polluted. Third problem with neonics is they are just all over the place. Virtually all conventional corn and upwards of half of soybean acres in the United States are planted with those neonics already on the seed, and that doesn't count sprays later in the season. That's already well over, upwards of 140 million acres. But they're also all over lawns, gardens, golf courses, pet products, bedbug products, you name it. Virtually anywhere there's an interest in killing a bug, there's a neonic product for that use. And to give you a sense of scale here, I know this is not this is a map of just use of one of 5 EPA approved neonic chemicals, not even the most used in agriculture. 2014 is the date we're using because that's the year they stopped tracking seed treatments, and most of the neonic use is on these coatings and crop seeds. But what you do get a sense of is, for just this one chemical, again, 1 out of 5, the vastness of the use across the country. And then when you realize there are other chemicals in use, and that if we were counting non-agricultural use, a lot of these spaces would be filled in. Minneapolis, St. Paul would be filled in. Chicago would be filled in. Indianapolis would be filled in. Detroit, Long Island. All of these areas where we know neonics are used in these urban settings would be filled in. And actually, because neonics are approved for much higher rates per acre in urban and suburban settings and on turf, we actually see in water contamination results sometimes these toxic hotspots in those areas where the water contamination is actually higher than it is in agricultural areas. So all this is to say that what we have is a situation where you're deploying an insecticide on a virtually unprecedented scale. This may be the largest deployment of an insecticide every sort of annually in US history. And because we're using them in the same places year over year, what's happening is we have a buildup of toxicity in the soil, again, that is expanding every time it rains into every nook and cranny of our ecosystem. Soil, water, plant life, wildlife, etc. So what's the impact of that? The first is that we know neonics are definitely driving bee losses. There was some debate 20 years ago. There is absolutely no debate now. Neonics are definitely harmful to bees and driving those losses. We've seen the connection with honeybees. We also see the connection with wild bees. And again, the thousands of species of wild bees. A good study came out just this past summer linking neonic use and also pyrethroid use to the loss of these wild bee populations and wild bee biodiversity. Another really good study came out over the summer looking at Midwestern butterflies. And this is key because Midwestern butterflies are one of the few types of insect species where we have these really long data sets because people will actually go out and count butterfly populations year over year. So we have this data that we can compare. And what this study found, and what was so important about this study, is that they compared the use of neonics versus other stressors, versus climate change, versus habitat loss, versus the use of other pesticides, right? Or even certain types of neonic use. And what they found is that the use of neonics was the #1 factor associated with the decline in these butterfly abundance and species richness, in particular for monarch butterflies. And the particular use, even within neonics, is the use of the neonic treated crop seeds. So, as mentioned before, honeybees were canaries in the coal mine for sort of what was more broadly happening with bee species and pollinator species across the country. Same thing for pollinators and all insects, right? We know that we're losing a huge mass of our insect life. And the anecdote that I like to give is, for those who remember driving around a rural area, say in the early 90s in the summertime, you would have to turn on your windshield wipers, whether it was raining or not, just to get all the bugs off of your windshield. And think about, when was the last time you really had to do that? I think maybe you can think of a time or two, but what used to be a very common experience is now exceedingly rare. And that's sort of the visible face that we see of this, what has been dubbed an insect apocalypse. But other species feel it more acutely. So we have seen studies linking neonics to the decline of birds and bird biodiversity, because unsurprisingly, birds rely on insects as an integral part of their food source. And we see the highest rates of loss associated with neonic use with the grassland birds and insect-eating birds. And this is part of, I don't know if folks saw this study that came out in 2019. In the last 50 years, we've lost 30% of our birds, 3 billion birds. And after this study came out, this study didn't look at neonics in particular, but after the study came out, another study was done that went into the data set of that study, and they teased out the two different types of bird species, those that relied on insects at some point in their life cycle, and those that insects were not essential. And if you look over the last 50 years, for birds where insects are not essential part of the diet, those birds are actually doing kind of okay, and in some cases doing a little better than okay. But really, it's the birds that rely on insects that have been getting hammered and losing population. And unfortunately, that's most birds. Same type of scenario happens in aquatic environments. So there was a good study in Japan that was looking at zooplankton. For those folks who are unfamiliar with zooplankton, these are zooplankton. They're essentially water bugs. And what they found is in the early 90s, the populations of zooplankton they have been studying since the early 80s basically hit a wall. And at the same time, fish species that ate the zooplankton also hit a wall because they ran out of food. And fishermen saw their catches of these species go down dramatically. At the time, people really didn't know what the cause was. The study authors later connected it to the introduction of neonics in nearby agriculture. And this is actually one of the first introductions of neonics in the world. They were actually approved in Japan before the United States. So, unsurprisingly, right, with these broad range of impacts, EPA a couple of years ago found that neonics are jeopardizing the continued existence of 200 plus listed endangered species. And I cannot stress what a wacky large finding that is. For those folks who know the Endangered Species Act, it is a no-no to jeopardize even one endangered species. I have never seen a jeopardy assessment this large, and we actually think it's an undercount, but it speaks to the phenomenal harmfulness and the widespread effects of the use of these pesticides. It's worth noting at this point that neonics are also directly toxic to things with spines. So they don't harm just insects. And one neonic treated seed has enough active ingredient to kill a small songbird if ingested. And on the question of whether birds eat neonic treated seeds, they definitely do. There hasn't been a ton of research on this, but there was actually a very good study that was done in conjunction with the Minnesota Department of Natural Resources, where they found actually it was fairly common to find birds eating seed spillage during planting season of some of these major crops, corn and soybean. Things start to get scary when we talk about deer. And there was a study done a couple of years ago. This grew out of hunters in the upper Midwest and West finding strange things happening with the deer that they had caught, strange things going on with sort of body deformities and organ sizes. And there was a thought that maybe it was connected to the use of neonics agriculture. So a controlled study was done feeding deer sort of real world level of neonic pesticides. And lo and behold, what they found is that these same connections, right? The deer exposed in the womb to real world levels of pesticides had birth defects, jawbone deformities, strange things going on with the size of their organs. There were increased fawn mortality, increased rates of stillbirth, And then in the adults, a host of sort of neurological and hormonal effects. The refrain from industry after this study was conducted that deer are just not exposed to these levels of neonics in the wild, so it was unrealistic, unrepresentative. But again, here we have a great study from the Minnesota Department of Natural Resources. They collected deer spleens from hunters in 2019 and found from deer culled all over the state, 61% of those deer had neonics in their bodies, and 29% at levels associated with those higher rates of birth defects and death in the Burheim study. But what's really scary is DNR redid that study just 2 years later, and what a difference a couple of years makes. 94% of the deer had neonics in their body, and nearly 2/3 at levels associated with higher rates of birth defects and death in the Burheim study. This finding actually really shocked me. Also really interesting, it didn't matter where those deer were caught in the state, whether it was a rural area, urban, suburban area, agricultural area, up near the boundary waters, it didn't matter. The results were similar statewide. What's really scary about those results is that they match what we see in human beings as well. So in 2019, CDC published a study based on 2016 data that found that on any given day, about half the American population had neonics in their bodies. And this is a study that looked at thousands of participants. A more recent study looking at data from 2017 and 2020 of pregnant women from across the country found that over 95% of those women had neonics in their body. And this is the truly scary part, that the levels and frequency of those detections increased over the 4-year study. And we know from some of the limited testing on people that, obviously you can't do controlled studies on human beings and pesticides, but on some population studies of populations that have been exposed at higher levels, we see very similar effects to the Burheim study: birth defects of the heart and brain, autism-like symptoms, cognitive impairment, and then a host of sort of hormonal effects, endocrinological effects in adults. This is also what we see in sort of the controlled animal testing as well. And I'll talk maybe a little bit later, although I might have to skip it. We think EPA is ignoring some of the science here, especially in the rodent studies where we see rodents exposed in the womb actually having thinner brains, thinner cortexes, actual changes to the brain, shrinkage of the brain. And then the question of, where do we get exposed to neonics? A lot of it comes through, or probably most of it for most people would come through food and water. Water, because we know water supplies become polluted with neonics fairly commonly, and most conventional drinking water treatment does not remove neonics from water supplies. And also food. Because of the way neonics work, they permeate fruits and vegetables, right? They're systemic. So you can't, when you have produce that has been treated with neonics, oftentimes you can't wash off the pesticide residue because the pesticide is literally used into the fruit or the produce. So, what happened across the world in terms of regulating neonics, curbing neonics? Europe in 2013 enacted a partial ban and expanded that in 2018 for the 3 most commonly used neonic chemicals. So that affects basically all outdoor uses. So most of the uses in Europe have been prohibited since 2018. Canada came close to a total prohibition at national level too, but backed off. Some of the provinces have gone further. In Ontario and Quebec, they've implemented verification of need systems, whereby farmers, if they want to use a coating, that neonic coating on the seed, they just have to get a prescription from their agronomist saying they're using it to treat a demonstrable pest problem, a real pest problem. And after implementing that system, neonic use dropped there to almost nothing. In Quebec, for example, in 2015, neonic use there looked very similar to the United States. 100% of corn retreated with that neonic on the seed, 50% of soybean. Those numbers fell by the second year of implementation of the program to less than 0.5% in corn and 0% in soybean. The reason being, and this is, what makes the situation almost criminal, is that the vast majority of use of these neonic treatments, the vast majority, provides no economic benefits to farmers. Very, very rarely do you get a yield benefit, but even when you get a yield benefit, it costs money to put the pesticide on the seed. So economically, it ends up being at best a wash in most cases, especially in these northern climates. The economics are a little bit different once you get to the deep south. So again, we saw this verification of need program implemented when people actually took a hard look. Do they need this neonic on the seed? What we found is basically nobody did, and we've seen almost no associated crop loss for switching to harmful alternatives or more harmful alternatives as a result. I'm going to move through some of the federal stuff quickly. There's a lot going on with neonics at the federal level right now. There's an endangered species consultation that the Federal Fish and Wildlife Department Service is looking at. They're evaluating neonics impacts on endangered species. The EPA finding is part of that. That's ongoing, and some restrictions could result from that process. EPA is also looking at neonics in a once every 15-year process called registration review. The purpose of that process is to make sure that all pesticides every 15 years meet the standard for registration, which is that they have no unreasonable adverse impacts on the environment, whatever that means. So that process is ongoing too, and is by law has to finish up in 2026. And then we also filed a petition to EPA to remove what are known as food tolerances for neonics in food. That's the allowable levels of neonics in food. We've asked the government to revoke those tolerances. All of those processes are happening right now. Unclear whether the change in administration will affect those timelines or whether staffing shortages at those agencies may affect those timelines. We haven't heard anything about that yet, but it is certainly possible that some or all of these processes could be slowed or shut down. This is one thing that I'll highlight very quickly, and again, what we think EPA is ignoring. This is a summary of the data that was submitted to EPA, and this relates to our Food Quality Protection Act petition, our food tolerance petition. We have laws in the United States that prevent levels of pesticides in food that are harmful to children and pregnant women and sort of developing neurological system of children. One of the ways we determine whether those pesticides are harmful or not is we have this data that's submitted by the pesticide companies themselves. And here we see that in the data submitted by the pesticide companies, all of the neonic chemicals showed brain thinning in the test animals, and no additional data was sought for most of those chemicals. The one chemical we did, thiamethoxam, we can see that brain thinning occurred in also the mid and low dose. And I won't get into the really technical weeds here, but basically we believe that the levels of safety that EPA has set are way too high, that EPA has ignored this data, again, that is showing brain thinning. Our staff toxicologist always likes to say, you can't ask a rat how it did on its second grade math test. Here's a scenario where we don't have to ask that question. We actually see thinner brains in the rats that have been exposed to these chemicals in the womb. Again, a real big concern because we know that there's such high exposure in the US population, and what we can see is that those levels are rising every year. So I may skip through some of this very quickly, but we think that there's a lot of low-hanging fruit in terms of the uses of neonics that can be limited. The biggest ones are the field crop seed coatings, which, as explained, really don't provide economic benefits to farmers. Lawn and garden uses are another great place to limit or prohibit those uses because neonics simply aren't necessary in lawn and garden settings outside of sort of a limited exception for invasive species. And again, those are uses that create really sort of toxic hotspots in terms of neonic contamination in the places where people live, play, and drink water. Very quickly, what's happened across the country. New York was the first state in the country to address the issue of neonic coatings on seeds through the Birds and Bees Protection Act. Vermont followed shortly thereafter with a very similar bill. And again, they're implementing this Canadian model, sort of if you need a neonic on your seed, just get a prescription, a verification of need model, which we think makes a lot of good sense. New Jersey was one of the first to completely ban neonic use in lawn and garden settings. Maine and Nevada have passed similar laws, and we've seen Connecticut and Vermont also look at similar bills. California was the first, is now coming up with a regulatory framework for controlling the use of pesticide-treated seeds directly. I didn't speak about it, but pesticide-treated seeds are not directly regulated as pesticides because of loopholes, legal loopholes at the state and federal level. Minnesota, a couple of years ago, passed a prohibition on neonics on public lands. And we have a petition in the state for the state to do more under its current authority under the Environmental Rights Act. And then a number of states have made neonics restricted use, which means that you can't find them at the store shelves at Home Depot or Lowe's, but they're still used by pest control specialists or lawn care companies, anybody who has a certified applicator. And those include about a dozen states now, which are listed at the bottom. So I want to skip ahead. I'll skip ahead to questions because I think I covered most of what I wanted to talk about. I'll just highlight for the Minnesota crowd, again, we have a petition to the Minnesota Department of Agriculture. It's under the Minnesota Environmental Rights Act. We think the department can and should and can do more and must do more to protect Minnesota's environment and Minnesota's people from the negative impacts of widespread and wasteful neonic pollution. So I'll stop there.